Okay, I'm gonna introduce how to use Excel to calculate the mean, median, and the mode. But just one thing I want to remind you that I strongly suggest you know how to calculate those values by hand. Okay, so I strongly suggest the hand calculations because hand calculation can help you understand more about the definition. About the more definition, when you calculate the mean, when you end up all the values and divide it by number of the values, you understand more how you get the average number. Okay. And in using Excel, it's gonna save a lot of your time. After you completely understand the definition, the meaning of those concepts, there no problem for you to go ahead and just use Excel. Okay, so using Excel to calculate those values is you use their typical formula. For example, in Excel, you type in the equal to the average, then you select the values in the data, then you can get the mean number. And for the median, just equal, then type in the median, and then include the selected values, then you will get a median. And same to the mode. You can also use the data analysis tool. Okay, so again in your Excel, then click the data on the top, and then select the data analysis, and then select the descriptive statistic option, then click OK. Then put the data, the objected data, in the input range, then click here. In this example, because the input range is A1 to A6, including the house prices label, that's why you click the labels in the first row. Okay, if you did not include the house prices, this cell, then you don't need click the label in first row. Then click the new worksheet and summary statistics, then click OK. You will get this. This is a summary of your output. So you get a mean number and median and the mode. Okay, so which method of the central tendency should we use? The mean is generally used unless extreme values exist, because that's gonna affect your mean number to make mean not representative. If outliers are present, then the median is often used, since the median is not sensitive to the outliers. And for categorical data, grouped data, then the mode is the best choice. So we kind of done with measuring the central tendency. Okay, so the goal of central tendency is helping us find out the center of the data and the most representative data. Okay, here are some examples, help us think about a question involved. Average annual income of executives for internet-related companies is 80,000, and for pharmaceutical firms is also 80,000. So this average annual income is the mean, right? We just learned that the mean number is the average number. So that's the center of the data. So it's kind of the representative. Okay, the salaries for executive in the internet-related firms range from 70,000 to 90,000. Means some people make the 70,000, some people make 90,000, but on average, the typical salary is 80,000. But in the pharmaceutical firms, okay, this salary range from 40,000 to 120,000. What does that mean? It means some people make only 40,000 and some people make 120,000. Okay, well, we again, we get the mean number is 80,000. So even though the average salary are the same for the two industries, but can you tell which mean number is more representative? The one for the internet firms. Why? Because in this industry, the data seems more, closer to the mean number, and in the pharmaceutical, industry, and the salaries or the data is kind of like widely spread out around the mean number, each value far away from the mean number. So this 80,000 is not that typical in the pharmaceutical industry. It's not typical. Okay, here come up with the next question, and we want to learn. That is, once we find the center of the data, we want to know if the center of the data is representative. How do we measure that? We're going to measure how the data spread or dispersed. Just like we use mean, median, and mode to measure the center of the data, and we use range, variance, standard deviation to measure the spread of the data and how much spread is present in the data. Range is the simplest measure of the variation, the dispersion of the data. So it's just simply the difference between the highest value and the lowest value in the data set. So range is the highest value minus the lowest value. The disadvantage of the range is it's only based on the two numbers in the data set. So the more accurate measuring of the data dispersion is standard deviation. To understand standard deviation better, we need to look at the variance first. There are different formulas for the sample variance and the population variance. The sample variance is denoted by S square. Remember this, okay? It's just like you need to remember the mu is population mean and X bar is the sample mean. Here, S square is the sample variance. So sample variance formula is like this. Looks a little bit, kind of difficult. So it is X bar again, sample mean, right? I told you to keep that in your mind because you're gonna say that a lot and you need to know that represent sample mean. So each value in the data set minus sample mean. Okay. Each value minus sample mean. Then square it up. And then we have this sigma sign. Sigma means the operation of ending, right? So we need to sum up all the difference between the value and the sample mean square. So n is the sample size. Remember here n minus 1. Okay, so xi minus x bar is the difference between each data value and the sample mean. So you can tell from the formula that the variance is trying to measuring that how far each value away from their center, from their mean number. Let's check example. Here are given data set. So we have 8 numbers, and the mean x bar is we sum all these values up, divided by 8, and we get a 10. S square, the sample variance equal to each value. Okay, each value minus mean number. So 4 minus x bar square plus 6 minus mean square plus 8 minus sample mean, then square plus, until the last number. Then divided by n minus 1. Okay, continue, then we finish it. We get 18.571. That means the variance measures the variability or spread of the data points around the mean. After we get the variance, we can find out the standard deviation. Standard deviation is the square root of the variance. Remember, for the variance, we square the difference between each value and the mean number, right? So to get the standard deviation, we need to take square root of it. So standard deviation is actually more accurately to measure how far each value away, the average difference between each value away from their mean number. Remember, we use what? We use ice. Ice represent the sample standard deviation. Ice, sample standard deviation. So sample standard deviation, we use the same example, is just taking square root, we get a 4.309. Okay, 4.309. That means on average, each value is 4.3 away from the mean number, is away from the 10. So standard deviation, this number is a large number. That means on average each data value is far away from the mean of the sample. If the standard deviation is a small number, that means on average each data is close to the mean of the sample. In other words, if the standard deviation is small, that means the mean number we get, the sample mean or population mean we get, is representative, is a typical number, means it's reliable, right? Okay. So we just took care of the variance and standard deviation for a sample, right? Remember, we use the ice square to represent the sample variance. We use ice to represent the sample standard deviation. And then now let's check the variance and the standard deviation for a population. So population variance formula is we use the sigma. Okay, remember we use sigma, not ice. Sigma square. And the difference from the sample variance formula is in the denominator we use a capital N instead of n minus 1. So mu is the population mean. Mu, say here we use a mu instead of x bar, right? Why? Because it's for the population. Mu is the population mean, n is the population size. So xi minus mu is the difference between each data value and the population mean. Therefore, the population standard deviation is sigma, take the square root of the population variance. Okay, so remember, keep it in your mind that we use the sigma represent standard deviation. Okay, so far there are 4 symbols you have to remember. That is, we use mu represent population mean. We use the x bar represent the sample mean. We use ice represent the sample standard deviation. We use sigma represent population standard deviation, because you're going to see them a lot in the later chapters, and without telling you, they're going to appear in the question, and when you see that, you know that means population standard deviation or sample standard deviation or population mean or sample mean, because some formulas are different for the population and the sample, just like the standard deviation, say different, right? Again, Excel can help us to calculate the standard deviation. It's gonna just click a button and you get the result. But however, I strongly suggest you go through several questions by hand calculation. Okay, only by hand calculation you can understand more about the standard deviation or the variance. You will understand standard deviation is measuring the difference between each value and their mean number. Okay. Then in the Excel, the functions for the variance and standard deviation gonna be like this. For the sample, it's VAR. Okay, VAR. Then you put the selected data values here. Then STDEV is for the standard deviation. For the population is VARP. okay, and the standard deviation is STDEVP for the populations. Then select the data values in, then you will get the standard deviations. Remember the difference. Okay. You can also use the data analysis to find out the standard deviation. Use the exact same way that we found the mean and median and mode. You just in the data analysis descriptive statistics tool, and they will give you a list of the data here, right? Mean, standard deviation, median, mode, standard deviation. Oh, sorry, here is the standard error, then standard deviation, sample variance, and range, and including skewness, maximum number, minimum number and maximum number, and the sum and the count, everything. Next is a very important concept which represent our application of standard deviation and mean. Okay, in order to make your learning of the later chapters easier, you have to understand and learn how to find this z-score. We also call it z-value. Z-value identifies the number of standard deviations a particular value is away from the mean of its distribution. So the z-value or the z-score is 0 for the values equal to the mean. Of course, because we are measuring the difference, right? So no difference, then it's 0. Positive for the values above the mean, negative for the values below the mean. Okay, a data value that has a z-value above +3 or below -3 is characterized as an outlier. Remember, okay, for a group of data, if you calculate the z-value of it, if your z-value is greater than 3 or less than the -3, that means that value is an outlier. Okay, so your conclusion should not be affected by this outlier. That means it's far away. That value is far away from the mean. So how do we get the z-score or z-value? How do we measure it? So the formula for the population z-score is z equal to x, any data value, minus mu, population mean, over sigma, population standard deviation. Okay. Formulas for the sample z-score or z-value is x minus x bar divided by s. See, now you understand why I keep telling you, please keep this in your mind. We're gonna use that a lot, so you should know, each letter, what they represent for, right? This is population mean. This is the sample. This is the population standard deviation. This is sample standard deviation. This is the sample mean. This is the population mean. Let's check this example to better understand the relationship between the z-score and the mean number and the standard deviation. Okay, so this example listing the calories for various fast food hamburgers, the different hamburger types from the different restaurant and their calories. Okay, so we calculated the sample. Those are the sample mean, right? Those are samples. Why? Because this restaurant does not include all the restaurant. It's only pick some restaurant, right? McDonald's, Wendy's, McDonald's, Burger King, only some. So it's a sample mean. So we found out the sample mean is 776.3 calories on average for the hamburger. Okay. Then the sample standard deviation is 385.1. We want to find out this value, okay, the Whopper in the Burger King, the calories of the Whopper in the Burger King, how far is this value away from the mean number. Then we calculate the z-value, because the z-value is, we measure the difference between the value and the mean number by standard deviation, means how many standard deviations this value away from the mean number. Okay, so 670 minus sample mean, right? 776.3 divided by sample standard deviation 385.1, and we get minus 0.276. So that means there is 0.276 standard deviation. Okay, there is a 0.276 standard deviation, the difference between the number and the mean number. And because it's minus, that means the calories of the Whopper in the Burger King is less than the mean number. Okay, empirical rule is showing us how useful the z-value is. Okay, according to this rule, if a distribution follows a bell-shaped symmetrical curve centered around the mean, then we would expect about 68 of the values to follow within plus or minus 1 standard deviation from the mean. Okay, 68% of the values gonna follow into this range. Okay, 1 standard deviation of the mean. So this 1 and minus 1 is z value. Okay, is the z score. 95% of the values fall into, 2 standard deviations away from the mean, and about 99.7% of the values fall into 3 standard deviations away from the mean. Okay. That's why we say if a z-value is greater than 3 or less than minus 3, right? Some value z-value is greater than 3 and minus 3, we call that outliers, because 99.7% of value inside this range. Okay. And any numbers outside this range, of course it is what? On euro. Okay, so far we are talking about how to find the mean, standard deviation, and all of those measures for raw data, just a group of the data. How about the data that we already organized them? Means we already put them into the frequency distribution or frequency table. How do we find out the mean or standard deviation for those kind of the data? We call the data we already organized in the frequency distribution grouped data. Okay, so mean for the grouped data, the formula is like this. The formula for the sample mean from a grouped data is like this. So x bar equal to r, about to approximate on the top, it's the sum of f times m. F is the frequency for each class. So f1 is the frequency for class 1, f2 is the frequency for class 2, f3 is the frequency for x3. Then the m is the midpoint for the class. Do you still remember that in the chapter 2 video I told you guys how to find the midpoint, right? So midpoint is the halfway of each class. How do we find out the midpoint? We end up the lower limit of the class and the upper limit of the class, then divided by 2. That's how we find the midpoint, right? And n is the total number of the observations. Remember, n is the total number of observations. N is not the number of the classes. N is the number of all the data. Okay. And the formula for the population mean for the grouped data is like this. Similar, exactly same. For example, let's check example for this mean for the grouped data. Okay. So for example, here are the net income of a sample. Large importers of antiques are listed. Okay, so we want to find out the average net income. So frequency here, number of the importers, and the times midpoint. So frequency 1 times midpoint 1. Frequency here is 1 times midpoint of the first class, right? So how do we find out the midpoint of this class? Remember the lower limit plus upper limit divided by 2. So 2 plus 6 divided by 2 is 4. That's I listed here. Okay, frequency is 1, 4, 10, 3, and 2, right? And the midpoint for the first class is 4. Midpoint for the second class is 8. We found by 6 plus 10 divided by 2 is 8. Midpoint is 12 for the third class, found by 10 plus 14 divided by 2, and 60 is we get 16 from ending 14 plus 18 divided by 2. And the last one is 18 plus 22 divided by 2, we get the 20, the midpoint for each class, and the frequency for each class. Then multiple frequency with by the midpoint. So 1 times 4 is 4, 4 times 8 is 32, and 10 times 12 is 120, 3 times 16 is 48, and 2 times 20 is 40. And then we're gonna sum them up. Means we end up all these frequencies times m. That is the number 244. We got by 4 plus 32 plus 120 plus 48 plus 40. Then we get 244. So we use this 244 divided by 20, right? The number of the values, we get a 12.20. So number of the values, remember the n is not a number of the classes, n is the number of observations. So n is 1 plus 4 plus 10 plus 3 plus 2, that is total of the frequency is 20. Okay. So again, if you have any questions, please let me know by email. Thank you.